Alright, welcome back. In this lecture we're going to have a brief look at the tools we can use in ROS. Whilst they are not necessary to run a robot, they are helpful for things like 3D visualization, logging data, plotting data, and also visualizing the system and its interconnections. Now the first tool we're going to have a look at is RViz. This is a 3D visualization tool. This will allow us to visualize our robot, and for this our model needs to be in the format of URDF, which is the Unified Robot Description Format. This model can just be a visual representation. Further, it can be movable, and even further, it can have the physical and collision properties. Now, further from this, RViz allows us to display a range of data from different sensors, such as distance to an object from, say, a laser distance sensor, as shown here on the slide. If further, it could be a point cloud from, say, a Kinect, or just video data streamed from a robot is able to be displayed here. So we don't need to create these tools, they're already there, and so we can use them for our visualization. Now, on the next slide, we can see the interface. The middle section here is the view panel, which you can visualize in 3D or 2D your data and or the robot or robots. And you can use your mouse to rotate, pan, etc. like you would in most CAD programs. The displays on the left hand side, these describe all the data that we want to display and how we want to display them via many options and parameters, which you'll have to go through and decide what you want and how you want it to look like for your particular visualization. We then at the top have a range of tools which include interact, move camera, select, focus, measure, 2D pose estimate, 2D navigation goal, and publish point. So these tools may be handy for what you're doing, and you can use them directly in RViz. And then on the right hand side we have the views. This changes the viewpoint of the view panel, so it doesn't always have to be this 3D view that you're seeing here. You can use orbit, which will orbit around a particular point. So you pick your point on the 3D axis and basically you'll orbit around that. You can go into first person mode from the perspective of the robot. You can go as a third person follower, so you can be in a third person mode. Think of it like a camera behind the robot that follows it. You can go top down and see it as a 2D view, and there's some other ones that you can check out. And then at the bottom we have the time, which we might need for some certain simulations. Now, if we go and add displays, we get lots of options as shown here. So I'm going to go through these fairly quickly. You'll have to experiment with the ones that you want, but I'll quickly go through all of them. So we have axes, which displays axes for the model. The camera allows you to add a camera view, so you can view your robot in the three-dimensional space, but also have a camera which would be from your robot, so you can see what it sees. You can have depth clouds and point clouds from something like a Kinect. You've got effort, which displays the force on rotary joints. You got fluid pressure, so you can actually show pressure of different fluids. So this could be air or water. You've got grids, you've got illuminance, you've got image displays, which will just show an image. You've got markers, so these are objects like circles, rectangles, cubes, etc. that are provided for from RVs. And these can be used as markers for your planning, or maybe using to indicate that you want to go to this particular position or something like that. Furthermore, there's interactive markers, which are the same as markers, but you can change the position and rotation of them using the mouse. You've got odometry, which will show odometry information in relation to time in the form of 3D arrows. Okay, so you'll see all these arrows as your robot moves around. Path shows the path of the robot, and this can be very helpful when you're doing path planning. Polygons, you've got pose, which is displayed as an arrow. You've got range, which visualizes basically a measured range, so this would be something like an IR sensor or a ultrasonic sensor. You've got the robot model, which will visualize the robot model, and if you've got movement, you can visualize that movement, as well as collisions, etc. You've got TF, which is the coordinate transform we mentioned earlier, and these are displays. This basically displays the axes for these, and then we have temperature and humidity. So there's quite a few tools here and displays that you can display. However, a lot more will be added with time. Okay, so this is a continuing development, and so you don't need to create all these. Next tool we have is the RQT graph. Now, you would have already seen this in the previous video. This basically allows us to visualize the nodes, the topics, and the communication between them. This can be very helpful in knowing how the system communicates, and the system is actually communicating and is interconnected correctly. The next thing we have is RQT plot, which allows us to plot 2D data on a graph, and we can save these plots. And this can be really handy when you want to visualize your data or just create a graph, and also just for debugging, because you can see it in a nice, clean, easy format, which may be very difficult in something like RViz. And lastly, we have RQT bag, and basically this will record the messages being passed through a particular topic, and then these messages can be played back and investigated. Further, they can be visualized on a graph as shown in the slide, and they can actually also be published. So for example, let's say you're recording some data from a sensor, and you record it using RQT bag. Then you could imitate that sensor by playing back that data and publishing, pretending to be that sensor and seeing the results. This allows you to do testing using real data, and it can be very helpful. Now, this is it for this short lecture. After this, we'll be looking at the Turtlebot, which is the robot that we'll be using for ROS. Thank you very much.